All right, this says, determine the intervals of the domain for which the function is continuous. Now, it says right here, continuous. Now, we're just talking, when we talked about domain and range before, we just talked about what the domain goes from. All right? But, if you was to, let me do it on here because I don't have my video set up. If you was to take, it's on the board over there, okay. If you was to take a straight line, and you was, which way do we read? Okay, you know domain is X values, right? Bam! What do we hit? We hit the function at what? 1 to what? What is this circle right here? Is it closed or open? Closed. So it gets a, what does 1 get? It gets a bracket. And then it keeps going to, what's this arrowhead called right here? Infinity.
What I did was I went to view an example. However, they solved the problem. That's how I taught you my answer.
Well, that's
I
not,
didn't understand it though.
That's not how I taught you. Boom.
I'm gonna do that when I get home.
Okay. Take your pencil. Boom. But that's what domain is. Where does the value start that you plug in? At 1. Now what is our range? Well, you got to take a vertical. Get rid of this guy. Well, we could flip it. I know. I'm good. All right, now let me mess it up. All right, here we go. Boom. Where does it start? And goes to infinity. That's your domain and range. Now, talk about increasing. How do you talk about increasing? Well, we get rid of our line. And we put our little plane right here. Oh, that's not the line maker. Hold on. Change it to this, and this, and this, and this, and that. There's our little plane. Well, you come up here and draw it. All right, now, where is that plane doing as it goes 500 miles? What is that plane doing? It's going up. So what's it doing? It's increasing. So increasing values are from 1 to what? To infinity. Now, not always is your domain and your increasing values going to be the same. But in this case, I'll blow it up. Hold on. I see some of y'all sitting in the back of the room squinting. I don't know why you're sitting in the back of the room if you're squinting, but
I can get out easy.
okay. Yeah, you got to go somewhere. All right. Great. I just erased it. Hit the wrong button. There we go. All right, there's your plane, and it's sitting at 1. And as it goes laterally, as it goes that way, what's it doing elevation-wise? It's ascending. And ascending, increasing, same word. Okay? So you good on that one? Let's look at a nerd. 3. All right? Now we know this is a cubic function or a 1 over, I can't remember, x squared. Be 1 over x. 1 over x function. All right, now, this is where you see the convergence. This is when you have a, I got to fix this thing so I can write. I can't write with that mouse. We know this has a horizontal shift of what? 4 to the right. So this is the f of x is equal to 1 over x plus, no, minus 4. Okay? Now we know it doesn't have a vertical shift. Why? Because it's what? It's on what axis? Now we went over all this. We went over the vertical and the horizontal shift and all that. It's right here. So this has a plus 0 right there. Remember the horizontal shift? We said that's the only time that if you move right, it's going to be what? Negative. And if you move left, it's going to be what? Positive. So there's your function if you need it, but you don't need it here. But what is the vertical asymptote? The vertical asymptote, that's that red dashed line. Red dashed line is called the vertical asymptote. And the vertical asymptote represents the undefined number. What number makes this function blow up? 4. If you plug a 4 in here, you can't use 4. Okay? So that line right there represents, that red dashed line represents your domain. You can use all numbers except for what? 4. So let's do our vertical line again. Take our handy dandy vertical line. You ready? We hit the function because this function keeps on what? Okay, so it's negative infinity. Oops.
Does that mean the beat slow down?
No, it beeps don't slow down. You can make them slow down if you want to. Why don't I hit 4? You cannot touch 4. Now that's called a limit, where you touch, use half a step, half a step. Do you ever touch the wall? No. If I take half of this step, if I take half of this step, if I take half of this step, if I take half of this step. Half of 2 is what? 1. Half of 1 is 1. Half is 4. Half of 4 is an 8. Half of 8 is 16. Half of 16 is 32nd. You never do touch the what? The wall. You get close to 4, but you never can touch it, because if you put 4 in the function, it blows the function up. It doesn't work. So you cannot use x is equal to 4. So what do we do when we get to x is equal to 4? We get up to 3.99, and then we what? Jump over. Yeah, we stop basically, or jump over and start another. So we go negative infinity to what? To 4, but do we touch 4? And that's why you got a parenthesis. If you can't touch it, it gets a parenthesis. You can't touch infinity, and you can't touch 4, so they get parentheses. And then it stops at 4 with a parenthesis again, meaning you can't touch it, and goes to positive what? Positive infinity. Now, you can also put 3.99999999999 here if you want to. And then put a bracket. But that 9 has to have a what over it? A repeating line over it, because it gets closer and closer to 4, but it doesn't touch it. Okay? Does that help you on that one? A little bit. Well, ask a question if you got it.
Okay, when you put the f of x stuff, when you put plus 0, it's plus 0 because they go on the x-axis.
It's plus 0 because, yes, on the x-axis there's no vertical shift. If there was a vertical shift, this I don't know what happened there. This you see where this blue line is encompassing the x-axis, it would be up here or down here. It wouldn't be sitting on the x-axis, so that's why there's a 0 right there. Okay?
And I get the 4, x can equal 4, I get that.
And that's fine. If you put all real numbers and x cannot equal 4 and it marks it wrong, I'll give you that on the test. Because it's the same thing. The parentheses tell you at 4 that you can't use 4. And you can say x cannot equal 4. It's the same thing.
I think 4 is the
Okay, this is the You put your plane here. I think we did a plane, did we not?
But on that one, it was always like it was either the point below it as increasing or the point above it as increasing. And that's what was confusing.
All right, well, let's get our plane. Let's construct our plane so y'all can make fun of it. Well, whatever. I tried to make a wing. I tried to make it three-dimensional. Just forget it. Huh? No, y'all gonna make fun of it no matter what. So, oh well.
It's a fighter jet.
Yeah, thank you. All right, so here's our handy-dandy plane, and we're starting from negative infinity. And as we go from negative infinity, well, we got to do our points first, because this thing breaks up, doesn't it? Right there and right there. Now those two vertical lines represent something that's happening with the plane. So from negative infinity, don't ask me why it does that. I don't know. I don't know why that circle's always there. All right. So from negative infinity to this point right here, as I go from negative infinity x-wise to that first vertical line, what is this plane doing? Increasing. So it's increasing from negative infinity to what? 3. And then at 3, it levels out to what? 5. So it's level at 3 to 5. And then from 5 to infinity, it's what?
Like I keep
Descend.
that, but you go back to the answers. One of the answers is like.
Well, wait a minute, I'm not finished yet. That's increasing and decreasing. So increasing is what? Negative infinity to 3. And that's that answer.
So you list out the increasing, decreasing in the book.
Yeah. Constant or level from 3 to 5. Now, some books will put parentheses on these numbers. I don't, because I think in three dimensions, a plane can be at a point for 1 millisecond. It can be there at that point. So that's why I put a bracket. So I disagree with the book there, and I will give you credit for it. And then the last one is decreasing. And decreasing is from 5 to infinity. Now it may ask us the domain and range. Let's go ahead and do that. Domain is what? 90% of the time your domain is going to be what? All real numbers. Negative infinity to positive infinity. I don't care how you write it. Negative infinity to positive infinity are all real numbers. That's all real numbers. That's your domain. Range is from negative infinity to what?
3.
To 3. And if you're not sure, take your handy dandy horizontal line. You're hitting the negative infinity to boom, 3. So negative infinity to 3. That's your domain and range. Now let's go back and look at the answers. Hold on just a second, and we'll get to your question. Close. All right, now let's see what the question's asking. The function is increasing in the open interval, negative. Okay, they're putting a parenthesis on it, and that's fine. But some math teachers disagree with that. Some agree with it. I disagree with it. Because I think at a certain point in time, that plane is doing both, leveling off and increasing. It's at a still position right here. So they're saying it's not inclusive. That's fine. Then 5 to infinity would be decreasing. And where is it level? From 3 to 5. And your domain is all real numbers. Range is from negative infinity to 3. Okay? I'm not going to worry about something as trivial as a bracket. Now, is brackets and parentheses trivial on other things? No. But on this, it is, because you're telling me that this isn't the same point in space. I disagree with that. I don't think you can divide half of 3 to go into increasing and half of 3 go into constant. That's what they're saying using the parenthesis. I will be very lenient with you on the test with this one. Okay? Everybody with me? I'm not going to worry about it that much. But if it's something like this, then yes, I would be. Because that's an open circle at what? -8? So the domain is -8 with a parenthesis to infinity. Range is from 0 to infinity. But you can't use 0, so it would be a parenthesis on 0. So that's where it's important. Or if it colored in, then you'd put a bracket on -8 to infinity, and then 0 would have a bracket to infinity. Increasing from 8, bracket, to infinity, parenthesis. Okay? Do you see where someone could argue about that point right there? It's about like I told you. Michael Jordan, from the top of the key going up, there's one point in time that he's actually what? Flying. Because he's either going up or what? Down. You can't say he's not flying because he's either going up or down. He is flying. Maybe for a millisecond. And that's what they're saying right there. They're saying use half of it for increase and use half of it for constant. You can't do that. And that's where I've got a problem. Okay, next one. Let's do a couple more in this one. Let's do number 11. All right, try this one. Write it down. It says complete the left half of the graph, y is equal to f of x in the figure for each of the following conditions. F of negative x is equal to f of x, and f of negative x is equal to negative f of x. So what would f of negative x look like if it was equal to f of x? A. So the function there is f of x. What would f of negative x look like if it was equal to that? Well, let's see. Let's take our handy dandy pre-algebra chart and let's look at the points for f of x. 0, 0, 2, and what? 1. And what's this one? 1, 2, 3, 4. 1, 2, 3, 4. Oh shoot, are these 2, 4, 6, 8s or what? 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4. 4 and 4. 2 and 1. 0 and 0. Is that right? Oh, yeah, you're right. All right. Now, what does this mean? What does that mean right there? That means wherever there's an x, what are you going to plug in? A negative. So what does that do to all these guys? So let's look at this. Negative 0, which doesn't exist. Negative 2. And negative 4. So let's plot those. 0, 0. I'll do that one for you. Negative 2, positive 1. And negative 4, negative 4. Dang old M. So which one of these? Okay, so we click A. Now, I'm just showing you how the best way to do it. If when you feel like you're at your wit's end and you don't know what to do, that's what you would do.
I thought the f of x graph was the straight line.
No, this is f of x right here. This is f of x. They're telling you that in the function, this is f of x. This whole thing right here. And they're asking you what is f of negative x. And that's where you plug in a negative, and I just did. This is f of x, and this is f of negative x.
So the graphs you gave us, it doesn't have to be a straight line.
No,
It could
be anything. Now, if I give you a algebraic graph if I give you a function, then it's going to probably make a straight line but this is what's called a piecewise function. It's two functions. Actually, f of x looks like, I don't know, 45 degrees, which is, 1/1, which is x. Y is equal to x. But this has got a negative slope, and that looks like f of negative x or something like that. So, f of x is equal to negative x of some kind. So you got a positive slope here and a negative slope here. So you got two functions here. But they're calling this function f of x. And they're saying, if this is f of x, what does f of negative x look like? And that's what that would be. Now, let's do the other one. F of negative x, did we get that one right? I pushed A, but is that it? Is that the only thing you're going to do? Where's B? Oh, submit. Oh, this is your homework. I'm not supposed to be doing your homework.
You're doing examples. We're actually supposed to do that. No, but we're doing this because you're talking.
Okay, whatever. Where's B?
2.4.
I don't see B. Okay, f negative x, that's this right here, is equal to negative f of x. What's another word for f of negative x? Negative what? Negative f of x. If the negative is in front of f of x, what does that mean? This means negative y, right? That's what it means. So for each of 0, 2, and 4, 0, 2, and 4, take the negative of each of these. Well, that would be 0. What's negative? Negative 1. Negative 1. And negative 4 is what? Positive 4. So negative f of x is this right here. So that'd be 0, 0, 2, negative 1, and 4, positive 4. So it looks like that. I don't know why it's not giving me a chance to do that, but
Because you gotta submit it and then it'll.
yeah, but
Why wouldn't negative f of x make the whole thing negative? Like the x and the
the
y?
y. No, just the y. Because that's y. This is y right here.
But that's what I'm saying. Wouldn't it be like, since f of x wouldn't be outside of parentheses, it wouldn't just make the whole thing?
Okay, yeah, you're right. You're right. I didn't see that. The negative x right there. So that would be negative and negative right there. I'm sorry. You're right. Thank you. Sorry.
It's hard being a genius.
Negative. What'd you say?
I said it's hard being a genius.
I know. Negative 2, negative 1, negative 2, negative 1, and negative 4, negative 4. Whatever. Negative 4, positive 4, be negative 4, positive 4, be up here. So it'll look like that. Which would be something like that. Okay? So you're right on that. Okay? Now, I can tell you right now, there's not going to be a lot of these on the test. There's not going to be a lot of these. There's not going to be a lot of these on the test. The one before that.
Keep counting wrong for a number of them? No, you need.
No, I'm in your review. I can't do your homework. It's just letting me go through and do it.
No, but it made you, when you submitted it, it made you kind of.
Well, go back and do it over. It ain't like it's going to count. It's going to count it. Do it again. Lord have mercy.
Jack,
I dang old do your problem for you and you get mad.
No, you count the whole thing.
Okay, it's time for, what time's class over? 11? All right, I got to take the roll. Y'all got to get out of here. Good gracious, fuss about everything.